An example of linear regression, cooking with Uncle Ben's rice. Here is the data from Uncle Ben's rice that usually appears on their packaging. We see here that we have half a cup of rice requires 4/3 of a cup of water. 1 cup of rice requires 9/4 cups water. 3/2 cup of rice requires 10/3 cups of water, and 3 cups of rice would require 6 cups of water. Now, because I'm trying to figure out how much water I would need based on the amount of rice I'm cooking, we choose rice as the explanatory variable, and the cups of water would be the response variable. So I put my data into a TI-8384 calculator, and we then run a linear regression and get a scatter plot. So here's a scatter plot of the data itself. We have 4 data values, so a cubic polynomial would fit it perfectly. Now we won't start with a cubic polynomial though, because the scatter plot is showing us the data seem to fall on a line. So we'll try fitting a line to the data. And this is a constant question between parties, is that do we want an accurate model or do we want a simple model? In most situations you will go with the simpler model, provided that it satisfies the criteria of being a good choice. And that's part of what regression analysis does. So we're going to keep the model simple, and we're going to start with a linear regression, and if that is it indicates a good choice, then we will continue with that. These are the results of linear regression as done on the calculator. So here we have our slope at 1.869 approximately, our y-intercept at 0.4255 approximately, and our coefficient of determination, r squared, at 0.9988, and our correlation coefficient, or our Pearson correlation coefficient, at 0.9994. Our model of choice is y equals to 1.87x plus 0.43, where x represents the cups of rice and y represents the cups of water. The r value, again the correlation coefficient, tells us how linear the data is. The closer this value is to 1 or to -1, the more linear the data is. And with an r value of 0.9994, there is a strong positive linear relationship. So a line, right now we have evidence to suggest that a line is a good choice for our model. The r squared value is called the coefficient of determination, and this value tells us how much of the variation is explained by the model. The closer this value is to 1, the more variation is explained by the model itself. So when r squared is 0.9988, as in our example, this indicates that over 99% of the variation is explained by our choice of the linear model. And this is a very high r squared value. It's basically giving us an indication that we are making a good choice for our model as far as how well it fits and how much the model actually explains with the data. Here we see a plot of the model itself with our data values as the small squares, and we can see that our line almost fits through these 4 points exactly. There is a little bit of a miss with the 3rd point near the middle of the graph, and this is why we don't have r equal to 1 or r squared equal to 1, is that our line is very, very close but not quite hitting all of the values. And this is typical in statistical regression analysis. And suppose we wish to make 2 cups of rice. How much water do we need? Well, 2 cups wasn't in the chart. So we're going to use our model, and we plug the number 2 in for x, and we get about 4.16 for y. So this is telling us to use approximately 4 1/6 cups of water when making 2 cups of Uncle Ben's rice. There are some cautions to be aware of though. Due to extrapolation, we cannot use this model for cups of rice less than 1/2 or greater than 3. The model may not prove to be accurate. Also, be aware that we are truncating decimals to the nearest hundredth. to keep some accuracy and also consistency with cooking measurements. So our values are approximations. Happy cooking!